Alright, so we are doing the test review. Remember, for this test review is a grade, so I'm going to be leaving some things blank. No, not for y'all. But I'm gonna leave some of it blank so I can take it as a grade. Okay, number 1, 2, 3, and 4 is just like what we did in the practice in the notebook. They're giving you two polynomials. The first one says find the sum, so you're just adding them together. So that it's like you're adding. Sum means to add. However, these are the ones that have the subtraction signs on it, okay? So, number 1, remember when we're adding, we're only adding the things that have like terms. So please remember, this has an x squared. We're only looking for other things with x squareds. So 5x squared plus negative 3x squared. 5 plus negative 3. That should give me a 2x squared, so that's for my x squareds. Now, for the 8x, are there any other x's? Yes, there's a negative 13. Yes, and please be careful. I don't want people thinking they can put 8x plus negative 13x. Remember, your calculator does not know what x's mean on this screen, only in the y equals, because it's going to give me a 0. You can put in just the coefficients. 8 plus negative 13, you can see what that equals. And that is a negative 5 for the x's. And then for the negative 10 and the 15, I'll just use like a little squiggly line. Negative 10 plus 15. We get a plus 5, exactly. Thank you very much. And I'm done with this. I cannot do anything else because nothing else is alike. All right. So for this one, you're going to be adding the x squared plus the other x squared. That's a negative 1. Remember, if you don't see a number, there's an invisible 1. Then you'll add 3x and a negative 5x. Then you're going to add negative 5 plus negative 2 and see what you get. I'm leaving that one blank for you. I'm leaving that one blank for you to try it. All right, number 3. Number 3 is where you have to be careful because there's a subtraction sign in between the parentheses. So that means nothing up here will change because there's no subtraction sign in front right here. There's nothing in front. So this is going to stay as a 4x squared minus 5x. However, back here, what changes is this negative. You have to distribute a negative 1 to all of the terms over here. And all that's going to do is change the signs, okay? This is what you should have learned and practice Monday, Tuesday, and Wednesday. Bless you. So that's a negative 2x squared. Now it's negative because I multiply it times negative 1. Now this will be a plus 8. Now this will be a negative 3x. Sorry, that should be a negative 3x. Now I just start adding things together. Because I got rid of that subtraction sign, now I can just start adding the like terms together. So let's start with the x squareds because that's the highest power. It's going to go in the front. So 4x squared and a negative 2x squared. That would be 4 plus negative 2, which is a 2 for the x squareds. Now I'm going to do the x's. Let's do the x's. Negative 5 and negative 3. Even though they're both negatives, I'm still going to add negative 5 plus negative 3 together. That gives me a negative 8x. And, oh, this is the only thing that's left, so I just bring it down. There's nothing else to combine with it, so just bring it down. Yeah, because remember, it was negative. Was negative, but this made it a positive, and it stays positive.
Oh, yeah, you're right.
So when you're doing this one over here, look, there is a subtraction sign. So you need to distribute All it's going to do is just change the signs of everything back here. The front is going to stay the same. The front is going to stay because there's nothing to change it that's in front of the parentheses. But back here we got negative 4x squared. Now that's going to be a plus 3. And then that's a minus 10x. Now I'm going to combine x squareds plus x squareds. Even though one of them's a negative, I'm still taking 5 plus negative 4. And then the negative 2 plus the negative 10. And then there's a plus 3 right here. Yeah, I know. There was a couple tissue boxes around there, but you know, we all used them up. So please find your final answer right here. Number 5, 6, and 7, you need to know what a perimeter wants you to do. Perimeter wants you to add up all the sides. Perimeter, they want you to add up all the sides. Stop being annoying. The pentagon shown is a regular pentagon. Regular just means all sides are the same. El mismo. Right? El mismo, the same. Oh, you a lie. If all sides are represented by the expression 5n plus 2, what is the perimeter of the pentagon? What does perimeter mean? Add up all the sides. What are the sides? Well, this is 5n plus 2. 5n plus 2. 5, they're all the same. All sides are the same. Stop playing with your calculator because you're probably going to think that this, oh, that's 7n plus 7. No, this 5n is separate from when you're adding the 2. So what's 5n plus 5n plus 5n plus 5n? You're just adding up all the sides. 5 plus 5 plus 5 plus 5. So for the n's, I got 25n. And then what's 2 plus 2? Plus 2 plus 2 plus a positive 10. That's it. I just added up all the sides. It's so easy, but you have to know what to do. You have to know perimeter means add. And then you have to know what 5 plus 5 plus, even if you don't know what 5 plus 5 plus 5 because you lost your mind, you can put it in the calculator. 5 plus 5. Make sure you put in the correct number of 5s. You're going to have to do the same thing for number 6. You could have, but I didn't want to get anything mixed up, so that's why I just kept it separate. Because I don't want to get the rules of exponents mixed up. Number 6, blah, 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 blah. What is the perimeter? Perimeter means add up all the sides. So for this one, we got 3n plus 5. 3n plus 5. And now this one is actually a hexagon, which means it has 6 sides. So once you add 3 plus 3 more, plus 3. Sometimes, like, when I add it, I'll check it off. Okay, what's 3 plus 3? That gives me 6. Plus 3 more. That's 9. So keep on going. Plus 3 more. Plus 3 more. And then plus 3 more. So I check them off as I go so then I can write my answer. Your answer is going to look just like this one, but it's going to be a different amount of n plus a different amount for your constant terms. 5 plus 5. I'm just giving you a hint because this, you're finishing the rest of this one on your own. Finish that one on your own. And next we'll move on to number 7. All right, moving to number 7. If you're still working on number 6, you should probably pause the video if you're at home. Number 7, find the perimeter. Wait a minute. We just found perimeter on 5 and 6. What does perimeter mean to do? Add up all the sides. Let me show you the biggest mistake for people that don't listen because they're messing with dry cranberries. The mistake that people make is they do 8, 9, 10. They add it up, 11x plus 9, and they think they're done. Because they only added 2 of the sides. You need to make sure you add all 3. So if you got this answer, which it always happens on the test, for people that wasn't listening because they was on their phone or something, you need to get the full perimeter, okay? But miss, how do I know? Well, for rectangles, this side is the same. These two sides are equivalent, And these two sides are equivalent for a rectangle. So now you can add up the rest of it and see what you get. And then we'll move on to number 8. I'll give you about 30 seconds. If you're Alright, number 8 is like a tile problem, but it's really just combining like terms. You have to know what a zero pair is. So, if you see a positive and a negative, the darker shaded tiles are negative. A dark one and a white one, these two are going to cancel each other out. So they disappear. Because a positive x squared and a negative x squared equals 0. So it cancels out. So this one, does this one cancel out? No, because it doesn't have a negative tile to go with it. So far we have x squared left. Now let's look at the next tile. Look at these. You have to figure out, is there anything that's going to cancel out? Do two negatives cancel each other out? No, it's a negative and a positive that will cancel each other out. So be careful. Because x, is there a positive x left? No. It's just a negative x that's left. Sorry about that, forgot to do that. There's a negative x that's left. But this one can't cancel because there's no positive to go with it. And then the little short dogs back here. Remember, two positive ones are not going to cancel each other out. It's actually a positive and a negative that are going to cancel each other out. And then there's another positive and a negative that will also cancel out. Because when we're combining things, if there's a negative and a positive of the same thing, so all of these got canceled, so what's left is a +1. Find your answer and circle it. Alright, so this is how I know people don't care or just circle the random answers when they choose A or B. It's like, no, those got canceled out. There was only an x squared left, so it could have only been C or D. Alright. Number 9, write the power rule in the following space. Remember what the power rule is. The power rule is if you see an exponent, where at? Yes, on the outside of the parentheses. If you see an exponent right there, then that means you need to do what with these exponents? Multiply. This is the only time you can multiply the little numbers together, is when you have a power on the outside. All right, we're going to use this rule down here.
How long? Just like 20 minutes away.
Oh, we need to hurry up then. Come on, let's hurry up and get it done. All right, so this one here, remember, yes, what am I going to do with this power on the outside? It's a 6. That means 6 gets times 7, then 6 again times 3, then 6, Z doesn't have a power. What does that mean?
It's a 1.
Yeah, so this will be, what's 7 times 6? Fill in the blank. What's 3 times 6? What's the new power there? And then, I'm just putting squares so you could fill in the powers. It should be easy, just multiply. 6 times 7, 6 times 3, 6 times invisible 1. Don't forget about your little ones. Alright, everything's positive. Everything should be positive. There should be no big numbers. Hey, do you have any big numbers in front?
No.
No, thank you. Now number 11, same thing. Because there's a power on the outside, I'm going to multiply it only times the powers on the inside. So that's going to give me x to the, what? X to what? Negative, yes, I multiplied negative 40 and then y to the 4. However, thank you, you cannot leave the x negative. You're not going to see that answer choice. What you're going to see is, okay, the y should stay on top where it is, but the x, it's now going to be pushed to the bottom, but it's no longer going to have a negative 40, it's going to have a positive 40, okay? So please remember that you can't leave a negative. When you're done with the problem, don't leave a negative exponent there. Push it to the bottom. Because the rule for negative exponent is, if you see that something has a negative exponent, you move it to the bottom. Well, it doesn't look like there is a bottom, but you make a bottom. And you turn it positive. It was a negative exponent, but I pushed it to the bottom, and now it's a positive exponent. All right? That's the negative rule. There's going to be a part of the test where you're going to have to match the rules. You're going to have to match the negative rule. You're going to have to match the power rule. And you're going to have to match the product rule. The product rule is when it looks like they want you, it's a multiplication problem. But do you really multiply the powers? No. You add the powers. So you add the little numbers as long as they have the same base. And that's the next part we're going to do, the next part of the review. Let me turn this off. Okay, good. Yes, there's a back. All right. Let's flip it over to the back, because this is where the product rule gets used. Remember, just because the product rule says to multiply the little numbers, are you also going to multiply the big ones? What do we call those? The big what? The big daddies. Aha, the big daddies. So that's a negative 35. I'm sorry, we're not gonna add the big daddies, we're gonna multiply the big daddies. But we're going to add the powers. I just want to clear that up. We're adding the powers, but we multiply the coefficients is the mathematical name. But if you want to be cool, you'll call them big daddies or big mamas. Okay? So A plus the other A. How many A's are over here? Invisible 1 plus 6 is 7. Now for the B's. What is it? How many right here? The little power is 5 plus some more over here. This should be the easy part. And then for the C's, on the number 15 on the back. Don't lie. Over here we'll do the same thing. We're not going to worry about the zero power yet. Wait till the end to take care of zero powers or negative powers. Wait till the end. So these are the big ones, the big mamas. What am I going to do with the big mamas? Multiply. That gives me 40. Now the little ones, I'm going to add. X's can only be added with the other exponents of the x's. So 24 plus 0. 24. Then for the y's, 0 plus 50. Thank you. And for the z's, 8 plus negative 25. Maybe you, please don't think you're too good to grab a calculator. That's 8 plus negative 25. Negative 17. Stop talking.
Okay.
Now we need to decide what's going to happen with this. When you write your final answer, everything else will be on top. I'm trying to help you set it up. I'm giving you a hint. All of this will be on top, but I circled this for a reason. Because at the bottom, you're going to have z to the, is it going to still be negative?
No.
It's going to be a positive 17, but everything else will be on top. The 40 stays on top. All of that stays on top. Now the quotient rule. These are all the quotient rules because there's fractions. These are the quotient rules because there's fractions. And the quotient rule means if you have some stuff on top and some stuff on bottom, we subtract the powers. Top minus the bottom. I don't care which one's bigger, which one's smaller. It's the top exponent subtract the bottom exponent. And I'll give you a moment before we move to 18 and 19. Top minus the bottom. But just because the rule for the powers is subtract, that doesn't mean you just subtract your whole life away. All the numbers you subtract. No. The powers you subtract, but the big numbers, the coefficients, you're going to do what the fraction says, 50 divided by 10. So whenever you do something with 50 divided by 10, that's going to be on the top as a 5, right? 50 divided by 10 is 5. Everything's going to end up at the top. Okay, now for the A. What's 8? Take away 3. 8 minus 3 is 5. Good. Now for the B's. 4 minus 7? 4. Take away 7? -3. Be careful. This C. Am I going to do any math with the C's? Like, am I going to have to subtract anything with the C's? No, so that's when it stays at the bottom because I didn't do any subtraction. If I would have had to do subtraction, then the C would have popped up on top. But C stays where it is because there's nothing to combine or subtract with it. So now I got to figure out, something's going to happen with these because I can't just leave a negative exponent left over. Remember, everything, this is going to stay on top, but these two, it's going to seem like they switched places. The 5, A to the 5 stays on top. But what else is going to be on top now? The C is going to be on top with which power? Positive 6.
Yeah.
And now what's going to be on the bottom? B to a positive 3. Yep.
I missed.
And number 19, you're going to do that one all by yourself. Yep. First, you're going to what? Divide the big numbers. And be careful because when you divide the big numbers, it's going to end up on top, -5. And then when you subtract your x's, whatever you do, subtract, it ends up on top. Same thing for the y's. It's going to end up on top. There's only one thing that has a z, so that also stays on top. Then after that, you need to figure out if there's anything that gets moved. So you're going to have x to the something, y to the something, z to the something. Then if anything has a negative exponent, it's going to get pushed down. So I'll give you a second for that one if you're watching from home. Pause. All right. Number 20 is just like 18 and 19, but they're trying to trick you because they're giving you an area, length, rectangle problem. It doesn't matter. Remember, if you need to find the area of a rectangle or a square, you multiply length times width. But if you're working backwards, what's the opposite of multiply? You're dividing. So you're taking the area and dividing it by the length. And now I need to use the same rules I used for 18 and 19. It's the same exact problem, but they're giving it to you in a different application. You had to know that area divided by length will give you the width of the rectangle. In 3 sentences, describe how you chose your answer. Well, you can start off with first, I set up a, what type of problem is this? First, I set up a fraction, or you can say first I set up a division problem. Now I'm going to actually start working out the exponent rules. Second, now what am I going to do with the coefficients? Yes, second I divided, or second I divided the blank. You can say the coefficients, or you can call it the big daddies. Or I divided the 35 and 5. Then I talk about what you did with your x's. Did you add, subtract, multiply, or divide the x powers? Then I subtracted. It should be subtracted the powers of the x's and the powers of the y's. So then I subtracted powers of x's and y's. Please leave him alone because he needs to be working. So then we can move on to this one here because any questions about 20? All right, so 21. I need everybody to understand that it says the following expressions are equivalent to x to the p. Write the equivalent expression and the value of p. I need everybody to understand, yes, there's a power on the outside, but only on the outside of one of the parentheses. This 8 only gets multiplied with this parentheses, which is the 4, the little power, okay? So this 8 times 4 is what? 32. This 7 stays like it is. Do I continue to multiply? No, because the power is no longer on the outside of the parentheses. From here, now you can add the powers. Now add the powers. So you'll have x to the power of 39, which means the power is just 39. And you'll do the same thing here. But this 2 is only for this parentheses. This 13 is going to stay. That's going to be x to the 13, but this power right here is going to change to x to the 10. Now you can add your powers and see what your final answer is going to be. All right. So be very careful. Do not continue to multiply. You've already got rid of the power on the outside. Number 23, same rule up here. You have to take care of the power on the outside first before you start doing any subtraction. So you're going to be using the power rule first, then you're going to use the quotient rule. Okay? So that means everything, does anything at the top have a power on the outside of the parentheses? No. So this is going to be, everything at the top is going to stay the same for now. Then at the bottom, this is when I'm going to start getting rid of my power of 2. Also remember, this 5, you should not be multiplying times a 2. Because it's only powers that get multiplied with powers. This 5, you need to take to the power of 2. So 5 to the power of 2, which is 5 times 5. 5, remember where your power of underneath the clear button, to the power of 2. That gives me a 25. X to the, now I multiply my powers. That's 6. Invisible 1, that's 2. Now I can start using the quotient rule. The quotient rule means to, yes, subtract the powers because we have a fraction. But remember, we're not subtracting the big numbers. Okay? Number 24, there's 3 answers. How do you know that what the value of 1 is? It's anything to the power of 0. Does this have a power of 0? No. Does this have a power of 0? Yes. Does this have a power of 0? Yes. Does this have a power of 0? No. So anything to the 0 power, there's going to be 3 answers for this one, equals 1. And then 25. Which of the following is not equal to this one? Remember what not, well, first of all, figure out what this one should be. This is the product rule. That's going to be r to the 8. So which of the following is not equal to r to the 8? And you're going to find your answer for that one. And that's the end of this video.